Piecewise functions are just functions that are broken up into pieces, and what that means is that on different ranges of x values, different functions will take effect. So, you might have a function, and piecewise functions are written with a bracket. It might be some other function, g of x, on some range, x is less than a, but it'll be some other function, h of x, if x is greater than or equal to a, for example. So what you need to be careful about with piecewise functions is that, for example, in finding their domains, not only do all numbers need to be represented by these inequalities, and if they're not, you know you have a gap in your domain. But even if this function, for example, g of x, seems like it has a discontinuity, or somewhere where you wouldn't have something in the domain, like dividing by 0, you need to make sure that that number is actually on that piece in the first place, because if it's not, then it doesn't matter. So let's look at an example of that. Let's say we have the function 1 over x if x is less than negative 2, and the function x squared if x is greater than or equal to 0. Okay, so let's see what's going on here. Now, first of all, what you want to note is we have everything less than negative 2, we use this. Everything greater than or equal to 0, we use this. There's nothing in between negative 2 and 0. So this range here, negative 2 to 0, is not in our domain. And I put a bracket around negative 2 because negative 2 would not be in the domain, because we only have things less than it. Now, you might think, here, if I divide by 0, that is not in my domain. However, this function only applies when x is less than negative 2. 0 is not less than negative 2, so this doesn't have any problems with the domain there. Now, x squared, when x is greater than or equal to 0, there's no domain problems with x squared anywhere anyway, so we don't have any problems except for that we don't have this. So, your domain here would look like negative infinity up to negative 2. We don't have negative 2, because that's not in our domain. And we then have 0 to infinity. We can include 0 because it's or equal to. So what this means is we don't have this section right there. So you can see, even though we have 1 over x, 0 is in our domain, because 0, when you're talking about x equals 0, you're using this function, not this function. So that's what you need to be